Now we'll draw H2O. Okay, H2O is nothing but water, and oxygen has atomic number 8. Its electronic configuration is 2,6. So I'm just going to draw the Lewis dot structure of oxygen. Okay, and it has 2 hydrogens. Okay, so I'm just going to draw a hydrogen here. I'm going to draw a hydrogen here. Okay, instead of drawing the dots like this, what I'm going to do is on oxygen, I will draw it like this. Okay, so it shares one of its electrons with hydrogen, and hydrogen shares one of its electrons with oxygen. Similarly, it shares one of its electrons with hydrogen, and it forms a bond. Okay, and these are called lone pairs because they are not forming any bond. So these electrons are called lone pairs. Let me just write that down. These are called lone pairs. And these are called bond pairs. Yes?
I have another doubt.
Yes.
Ma'am, for like covalent equations, I know that in order to gain stability, we have to add an electron. In that way, we can, ma'am, I mean that why can't we just lose electrons even after sharing? Maybe like crossing it out. For example, boron.
Okay, boron has atomic number 5. Okay.
Yes, ma'am.
So boron atomic number 5, electronic configuration 2,3. So I'm just going to draw the Lewis dot structure of boron. 1, 2, 3. Yeah, now tell me.
Ma'am, we can add, but like, why can't we reduce those electrons? Can we reduce electrons even after sharing? So, like, even after sharing, can we reduce them?
No, sharing itself means that you're not losing the electrons. You're just sharing the electrons.
But it also doesn't mean that it is adding an electron.
No, it does not mean you're adding an electron. So that is what sharing means. So look at this. Look at water. Okay. And in water, what is happening? Oxygen is sharing its electron with hydrogen, and hydrogen is sharing its electron with oxygen. This way, what happens? Nobody is giving away their electron, and nobody is taking somebody else's electron. They are just sharing their own electrons, so that hydrogen ends up having 2 electrons. So it satisfies the duplet rule, and oxygen ends up having 8 electrons in total, so that it satisfies the octet rule. So nobody is losing anything and nobody is gaining anything. They are keeping whatever they have and they're sharing with other atoms.
Okay, ma'am.
Okay, yeah, that is the meaning of covalent bond. And ionic bond meaning transfer of electrons. For example, if I have NaCl, in NaCl what is happening? I have 1 electron, Cl has 7 electrons in the outermost shell. So I'm just going to draw the Lewis dot structure. In this, what is happening? In this, they are not sharing. In this, sodium is transferring to Cl. Now, what will happen if they share?
Like they are giving and not sharing. In that way, chlorine can get 1 more to be stable, and sodium can also be stable.
Yeah, exactly. So what happens in this case if, let's say, let us assume that they are not.
I understood that in ionic bonds you can add or like you can gain or lose electrons within transferring, but in covalent bonds you don't add or you don't lose anything.
Excellent. Yes, very good. All right. So you understood, right?
Ma'am?
Yeah.
Ma'am, so does it mean that in covalent bonds, both the pair they are noble gases, but in ionic bonds, like only one can be stable, the other one it's already taken.
No. In ionic bond also both will be stable. Let me show you. For
Ma'am, but in
example,
NaCl it's Na is 0, right, after it's shared?
not really. Look, sodium has atomic number what? 281, right? Chlorine has atomic number 7. So when sodium gives away this electron to chlorine, chlorine ends up having 8 in its outermost shell, so it is satisfying the octet rule. And sodium has 8 in its outermost shell, so it is also satisfying the octet rule. All right. So we were talking about water. So what happens? This is how water ends up forming covalent bonds because it's sharing its oxygen is sharing electrons with hydrogen, and this is how it happens. Now the structure of water is kind of little different. What happens is these two pairs of electrons, they are called lone pairs, right? So these lone pairs, they occupy more space. They want more space to themselves. So what happens? They will push the other lone pairs aside. They'll push them away from themselves. So actually the structure of water will look something like this. So they will push them away, and the structure of water will end up looking like this. Okay, so this is the structure of water, H2O. It is like this because it has two lone pairs, and lone pairs occupy more space and they push the other pairs downwards. So that is why this is the structure of water. Is this clear to everyone? Okay. So this is what the structure of water is like. Okay. Okay. So the homework this time for you guys is to draw the structure of H2O2. Okay. This is the homework. All right. So with this we are done with covalent bonding. We are done with structure of atom, electronic configuration, all of that stuff.